Molecules only relate to covalently bonded compounds. There are no molecules of ionic compounds.
No molecules.
No molecules of ionic compounds. I almost did it again. I clearly didn't have potatoes.
Lunch.
Okay, so
Be lunch, right?
if we have a chemical compound whose little pieces and bits are held together with covalent bonds, it's made up of molecules. If it's made up of molecules, it's called a molecular compound. That seems pretty self-explanatory, right?
Yeah.
So if something is a molecular compound, what kind of bonds are holding it together? Covalent. Good.
So
This becomes real important. On Thursday, we're going to be doing a lab where we're going to be comparing. I know, we haven't done a lab in a while. I'm sorry. On Thursday, we're going to be doing a lab where we're comparing the properties of molecular compounds and ionic compounds. Okay? They have very different properties. Questions?
So does that mean all covalent bonds are molecular?
Yes. If it is held together with covalent bonds, the substance that forms is a molecular substance. Question?
What happens if it has both covalent and ionic?
You mean in terms of like a polyatomic ion?
Yeah.
It's still an ionic compound.
Okay.
Okay. All right. So we're going to start to talk about chemical formulas. This is where we get back into some more math. Different kind of math, but more math. Woohoo! Woo! All right. So you've seen chemical formulas. You probably wrote a few of them in physical science. Depending on who you had, you may have written more chemical formulas or fewer chemical formulas. Okay. Yeah, you probably had some in biology too. So there are two different kinds of chemical formulas, and we're going to talk first about molecular formulas. So a chemical formula just tells you how many atoms of what type are in a substance. You're all familiar with the formula for water. What is it? H2O. That means there are 2 hydrogens, 1 oxygen. Pretty simple, pretty self-explanatory. In a molecular, that's only true though in a molecular compound. So in a molecular compound, the formula actually tells you the exact number of atoms of each type. Sugar, C6H12O6. Write it down, C6H12O6. And that's molecular. It's held together with covalent bonds. In every molecule of that, Daniel, how many hydrogens? 12. In every molecule of that, Destiny, how many oxygens? 6. In every molecule of that, Haley, how many carbons? 6. Individual molecule made up of 6 carbons, 12 hydrogens, 6 oxygens. Because it's molecular, it gives us an exact composition. One other important thing to note here are we have these things called diatomic molecules. The prefix di, di, refers to how many hold up fingers, don't yell it out. 2. Di and bi both refer to 2. So there are 7 elements that only exist in nature as diatomics. Okay, name me one, Grant.
Hydrogen.
Hydrogen. Anybody know any others? Sometimes it's called the heavenly 7. Okay, Trent, give me one more.
Oxygen.
Oxygen. So we've got hydrogen, oxygen. Know any others?
Chlorine.
Not helium. Helium's a noble gas, remember. Okay. Okay.
What was the 2 name here?
Hydrogen and oxygen.
That's a question.
There are 7 that occur as diatomic molecules. So we've got 2 names. Anybody know any others? There are 5 more. Di means 2 atoms bound together. So oxygen never runs around alone. Okay? Oxygen always appears in this, when it's on its own, free in nature, it's 2 bonded oxygen atoms. Hydrogen does the same thing, never occurs on its own. When it's on its own in nature, it's always in this form of 2 hydrogens side by side. So what I'm going to tell you is get out your periodic table. You're going to mark the heavenly seven. Okay, we got 2. Trent, name me another one.
Nitrogen?
Nitrogen is another one. So far we've got hydrogen, nitrogen, oxygen. Grant, can you name me one more?
Fluorine.
Fluorine. So fluorine is always going to occur. And we have nitrogen. So we're up to 4. So anybody who I have not heard from? Want to take a guess, Steph? Not carbon. It's a good guess. You're seeing a pattern. You want to take a guess, Taylor? There's a pattern here. No? You thought you had a guess?
I thought it was carbon, yeah.
Oh, okay. Give me one more.
Chlorine.
Chlorine. So now do you see a pattern? So we've got nitrogen, oxygen, fluorine, chlorine. Somebody I have not heard from. Want to take a stab? Are you seeing a pattern now? No? Worst you can be is wrong. And that's not terminal. Okay, that's a good stab. And why are you, it's not correct, but why are you guessing sulfur? Well, it's kind of over in that corner, isn't it? You wouldn't go pick iron. That's way out here. So you're all cueing in on the fact that it seems to be this corner of the periodic table.
Bromine.
Bromine. Good. Correct. Okay, anybody else want to take a stab? So we're up to 1, 2, 3, 4, 5, 6. We got one more. You want to take a guess? Iodine. Okay, so those are what are called the heavenly seven. Those are the ones, they're all gases at room temperature, and they all exist as diatomics. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So it goes in that little L in that corner.
Why is hydrogen?
Oh, and hydrogen, remember how we said hydrogen's kind of a weirdo? It's arranged like a group 1, but it acts like group 17. So that's why. Okay. Wunderbar. So we know that a molecule of N2 has how many and what kind of atoms in it, Leanne? N2 would have how many and what kind? 2 nitrogen. Okay, good. So that's a chemical formula. It's a molecular formula, so it gives us the actual exact number and type. Now, this is where we get into cutie pie and best friend. Cutie pie and best friend. All right, so protons and electrons. Show me with your hands. Are they attracted or repulsed? Proton and an electron are attracted to one another. They have opposite charges. A proton and a proton. An electron and an electron. Okay. This is constant dance. So I'm going to weave you a story about cutie pie. Cutie pie, the object of your affections. That individual who you just have the most desperate crush on. You're so attracted to cutie pie. Cutie pie is just everything that one could ever want in a partner. You really wish cutie pie would go to the dance with you. Okay? Ah, cutie pie. Unfortunately, cutie pie has got the most obnoxious, horrible, repellent, awful best friend in the world. And cutie pie and best friend are never